different approaches I see happen a lot for building. Specifically, I'm going to talk about commerce here, or a sort of a subset just to illustrate things, but it applies in other spaces too. I've seen it in IoT, connected vehicle platforms, back office type things, even just sort of, smaller web app or mobile experiences. So I'm going to start with what we call the monolith. This has been around forever. Typically, you've got a database of some sort that you have a platform sitting on top of it. And this sort of came about in the web era, right? Late 90s, early 2000s, browser-based experience. You've got a core platform with code modules inside it. For example, here's the product detail page. Uses a page template. It's rendered server side and sent back to the browser. The development team all works on modules that sit on top of this platform, which sits on top of this database. The database has, different tables inside it. There's a lot of flexibility here. It gets a lot of bad press. A lot of people argue it can't scale or won't scale or it's too expensive to scale. I think technically that's a bit of a ruse. Maybe if you're Amazon, this might not be realistic, but I believe they were in this model for quite some time at massive sort of runtime scale. What I will say can cause a scaling problem is if you get too many disparate teams playing around in the code base or in the database, it can be difficult for them to operate independently, right? Because this is typically all one deployment unit. It's all built together and deployed together. At runtime, there's only one database typically. If I have a change over here that I want to get out quickly, but someone over here has an in-flight change that can't go, either we need to have a sort of glorious branching model that causes now reintegration problems, or I've got to wait. The other thing that happened here as we move over towards, let's call it the later 2000s into the 2010s, these guys started popping up mobile apps. Caused a problem with this model over here because this was sending HTML back, although there was and still happen to be mobile apps that effectively are a browser inside. The more common way to do this would be now, instead of server-side rendering your HTML and sending it back to the browser, the core platform now just has APIs, and there's sort of split the back end and the front end. The front end is a mobile app or a browser. If it's a spa or some sort of CMS as Glass or other platform like that, the browser calls APIs back on the back end platform. The nice thing is here, you've now decoupled your front end changes from your back end changes. This team can operate on styling and other front end concerns independent of this team. You can even deploy this independently. Same with the mobile team. One thing I'll say, these guys are still, all those remaining problems of this all being tightly coupled and deploying new API changes still exist. It's slightly better in this model. What I've seen happen, however, is folks forget that if I need new data up here or over here, or I change one of these, I've got to make sure every client that's using these APIs knows about it. And if one client needs a change or a new feature, you really can't go any faster than you could over here, because these are typically all deployed and built together, and you have that same sort of, either you go down this crazy branching reintegration model, or you've got to wait for whoever the last person on the train is. The reason it's a little tongue-in-cheek here, but it's more expensive, slower, but buzzword compliant. It has APIs, microservices, it's headless, it might even be cloud native. The reality is, this is probably the worst of sort of optimal over here or optimal over there, or even a good middle ground here, because you've added complexity in here. By the way, folks forget this container management. That's a whole new discipline that folks need to deal with. Often I see Docker containers. They're using AKS, GKS, some cloud providers tooling, all new sort of competencies. Typically, they add an API management layer. I see folks who say, well, if my cart API, everything goes through the API manager, and if my cart API needs to call the product API, I either call API to API, or if you're really in bad shape, you call cart to API manager back to product API, which calls down into this platform. But the reality is it's probably better to just do it in here. And there's a mythology around, yeah, but I can deploy this, at will. I have no dependency on anyone else. However, these APIs are tightly coupled 99% of the time, so you're still blocked by this back here. And now what you've introduced is a bunch of complexity up in here that slows you down, both in delivery and at runtime, because these are typically separated by a network hop, where this could just be calling another API inside a single VM, or even talking through the database. And there are reasons that might be bad from a separation of concerns, but the reality is just adding these things on top doesn't help. I honestly, I've never seen a case where this has been useful, other than, and I'm just going to be a little bit snarky here, padding someone's resume or, being buzzword compliant. Typically, when we're saying composable, and by the way, folks tend to call this composable or mock or something like that. It's not. The reality is this is what we call a distributed monolith. And the characteristics are you have the illusion of composability or separate components that can be built and deployed independently and assembled somewhere else. But because they're tightly coupled to this legacy platform or platforms, you don't get the value. You just get the cost. And by the way, this is probably going to look horrible, me moving around like this. Folks will claim that being able to deploy this independently has some value, and maybe it does, but tracing through a call on this, right, does your API management layer expose enough data, and do these containers or whatever you got going here expose enough data to trace through from a mobile app going through the API manager to this, bouncing to that, down into this, down in the database. In these legacy platforms over here, all this stuff down on the bottom, typically there are rich and robust APM tools. A lot of this stuff is just emerging still. And I frequently see, I see the browser hit because I've got that instrumented. And then it sort of goes through this API management layer. Maybe I have some logs. I can search for a correlation ID. That takes me a while. And then maybe these guys have logs and I search for a correlation ID. And then and then the story is, I'll just use logs to tie that all back together. Again, that's a lot of engineering work compared to drop Dynatrace on this guy over here or New Relic or something. You get end-to-end visibility very quickly. Even if you've got third-party systems integrated on the outside, at least you can see that it left your system and came back. In this, everything's an external system. The other thing I'll say is these are typically separated by networks or VMs. You're talking an internal call here might take a couple of microseconds to maybe a couple of milliseconds to maybe 100 milliseconds. Often here you see 5-10x that time. And folks who write these, who came from this world or don't fully understand the architecture, haven't been explained, they treat a call, an API call to here and here, as if you're calling native code here. And it's hundreds, if not thousands of times slower. So you'll see things like in the cart, I've got 100 items in my cart. I'm going to call this API 100 times, which calls this API 100 times, which in here, this typically is really fast. But you've got all this latency on these interconnects that in here it was, like pointer reference change and maybe a database call. Now you've got all of that, plus you've got these multiple network hops. So that you'll see phantom like, well, this in itself only took 2 milliseconds. And this in itself only took 2 milliseconds or 20 milliseconds. And this only took 20. But this guy sees 200 or 300 milliseconds. And that's the extra network latency and not thinking about a network call is expensive. And folks pretend the network's free. I mean, that's one of the common distributed computing fallacies, right? The network is not free. And in contrast, you come over to what I consider the value of doing some of this work is a more separated, and I call it composable. It's really a distributed computing model. And in sort of the current, what I would say, state of the art, you separate those components that were previously all in the single platform into their own deployable units and managed units, right? And the product owner has a team that can do everything from design, build, deploy, version, everything around their API. And I still haven't quite figured this out. Then your clients, be it a browser or a mobile app up here, I don't know why I move these around, they use the contract of the API to make calls. There is a bit of a, I'll say, philosophical problem here, because often I'll see organizations that move from sort of new to digital, they treat web like it's everything. And so they may divide up and say, hey, I'm the product details person. I also own the front end. I personally think that's a bit of a mistake. The front end is their client. It's their direct customer. These folks can make requests for new data, but it shouldn't... my controller stopped working here. But it shouldn't be that you tangle front-end concerns with the API details. These folks should be serving these folks. And, I'll point out another bit here, because you see GraphQL Gateway was added in. A common mistake, even if you get to this really nice sort of clean separation of concerns, maybe it's domain-driven or functionality-driven, folks sort of treat this API as if it's going to serve everyone's needs. And what happens is you get these bloated APIs that are really end up, frankly, being slow, because you don't know what someone's going to need, so you just pack everything in a gigantic payload. A way to combat that is to use something like a GraphQL gateway with maybe finer-grained APIs back here. This GraphQL gateway lets the mobile app and the browser decide what data they need or what operations they want to do, instead of trying to presuppose an aggregate API that takes into account all of the different pieces of functionality you need. The other bit that I think is important and folks forget about is these things might still need to talk to each other. And a common mistake, much like we saw over here, is we'll have them directly call each other. Well, if search is directly calling product details and product details is down, search is down. And it sort of continues the tight coupling problem that we have over here and over here, actually in all of these. To combat that, these guys might actually have read-only copies or caches of data, and it might be a complete copy of the data. As long as they're not managing it, that's perfectly acceptable. That's on them. What you need is a way to record change events, and you need a way of thinking about what happens if the data's old. A lot of times folks want this data over here. They keep this because they treat it like it's a transaction to read a product info, and it's not. That shouldn't be if you're thinking about even inventory and pricing as transactional concerns, you're doing it wrong.